Hello class, this is lesson 2-1 in your algebra textbook, and today we're going to be talking about square roots and also real numbers. Some stuff that you've heard about before, but let's just make sure that we understand what we're talking about. So if you recall, we did the square of a number or cube of a number before, so today let's just remind ourselves that 4 squared equals 16, because that means 4 times 4 equals 16. I can also get 16 if I compute negative 4 and square that, right? Negative 4 times negative 4 is also 16. So I can get 16 by having both the positive and the negative version and squaring it. So sometimes you might see this symbol, plus or minus, and that just means that both the negative and the positive, I'll write positive first, positive and negative can give the same answer when we square it. Awesome. So in general, if b squared, so if some number is being squared and e equals a, then we're going to say b is a square root of a. Okay? So many times you're going to see the symbol that looks like this, and we call this radical 25. Radical 25. Okay? You might also say square root of 25, but this symbol right here is the radical symbol. It's radical, dude. You cannot ever take the square root of a negative number, though. Never. Okay, so write that down, put some big exclamation points. If you're trying to take the square root of a negative number, it can't happen, because what's negative 9 times negative 9? Well, it's going to give me a positive number, right? So whatever is inside, which we call the radicand, it always has to be a positive number. If you're given a problem when it's negative on the inside, then you're just going to write no solution. It's not something that you can do. So here's a couple of examples. If I have the square root of 36, what would you tell me the answer is? Well, it could be 6, right? Because 6 squared equals 36. It could also be negative 6. So if you want to write it the fast way, you could say plus or minus 6 as my answer. But sometimes they might be specific, and they might say, what is this negative square root of 4? Well, that means for my final answer, it's going to be negative, because really this is like an imaginary negative 1 on the outside that I'm multiplying by the square root. And so negative square root of 4 would just be negative 2. We're not going to write the positive version of that. Okay? So let's move on. Let's do some stuff that you've done before. Let's talk about perfect squares. So if I were going to square 0, 0 times 0 is just 0. Easy. 1 squared is 1. 2 squared, that means 2 times 2 is 4. 3 squared is 9. So say to yourself what these are. 4 squared is 4 times 4, that's 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 squared is 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. I always remember those because the last 2 digits you write in reverse. And 15 squared is 225. If you don't know all of these by heart, you should probably try to memorize those. Even you can go up to 20, and I would say that you're on the right track of being really successful in math the rest of your life if you can have those memorized. So these are called perfect squares, all right? So if you're asking, being asked a question, what is the perfect square of 100? It would be 10, okay? But sometimes you might be asked, what is the square root of a certain number? And it is not one of these special scenarios up here. Like for instance, what's the square root of 103? Well, all I want you to do, because you can put this in a calculator and it'll give you some really, really long number, but I just want you to estimate. So approximate for me, what is the square root of 103 going to be close to? Well, I would say it's pretty close to 100, right? So the square root of 100 would be 10. So I'm going to say that would be pretty close to the number 10. It might be 10.124, I don't know, something like that. Here's another one. What is the negative square root of 49? Well, that one I know by heart. I already know 49, and the square root of that is 7, so I'm just going to put my negative symbol. So that one was easy. Let's do one more though. How about the square root of 199? Okay, so let's look here. What is it really close to? So I can just say, oh, it's close to 196, and the square root of 196 is 14. So I'm going to say that that's going to be really close to 14 if you put it in your calculator. Okay, so here's the last thing that we're going to do, is we're going to talk about all different kinds of numbers. So in general, there are real numbers, and then way over here in the distance, there are these, well, they're called imaginary numbers. And you are not going to see these until you're in high school. So just pretend that they don't exist for right now. And so with real numbers, we have all these different divisions. So go ahead and draw this diagram. The main division that you started off with in kindergarten, they're called whole numbers. And this is the smallest group of numbers that we have. Okay? And these are those counting numbers, like 1 and 2 and 3 and 4 and so on. And also the number 0 is in there, included with the whole numbers. Now, something that we learned in the last chapter was talking about integers. And we said that integers can be those positive whole numbers, but it also could be those negative versions. So it could be negative 1, it could be negative 18, it could be negative 105, okay? Those are just some examples of integers. So integers is this entire box, all of those positives and negatives and 0, okay? After that, we have two divisions. On this side, we're going to start with the rational numbers. So let's write that at the top, rational. Okay, and rational numbers are numbers that can be written as the quotient of two integers. So quotient means division, right? An example for this could be 1/2. So it is an integer divided by another integer. Okay, it could also be negative 18 over 19, that fraction. So rational numbers a lot of times look like fractions, when we know that we can write fractions as decimals as well. So I could just say the decimal 0.75. Okay, those are all rational numbers. So how about we write ourselves a note that rational numbers are the quotient of two integers. Okay, that's what a rational number is. And so this includes this blue box because I could write negative 18 as negative 18 divided by 1. And that's also a rational number. Or I could write 3 as 3 over 1. And that would also be included in the rational number. But just these ones right here that are in this green section only are ones that cannot fully be divided into a whole number or into an integer. Okay, so those are rational numbers. So the other side then are irrational numbers. I-R-R-A-T-I-O-N-A-L. Okay, and this is kind of what we just learned. That maybe if I put the square root of 2 into my calculator, it's not going to come out to be some nice fancy number. it's going to be a long, ugly decimal. So it might be like 1.1412, and just going on forever. Or we know pi, right? Pi is 3.14159, and it just keeps going. So these are irrational numbers. A lot of times it's going to be the square root of a number, and it's something that continues to go, and these ones cannot be written as the quotient of two integers. So don't be confused, because sometimes you might have the fraction 1/3, and if I put this in a calculator, it's really 0.33333, and it keeps on going. But this can still be written as two integers being divided, where the irrational ones cannot. So real fast, here are 3 examples that I want us to classify. So for the square root of 24, which categories would I say that it would be? Well, I'm going to say that it's going to be a real number, because that is the whole classification. But when I put this in a calculator, it's going to go on and on and on, so it's going to be classified as irrational as well. Okay. Here is my next one. It is the square root of 100. Okay. This is a real number. And then I want to ask myself, do I know the square root of 100? Yeah, it's 10, right? So it is a whole number. But square root of 100 could also be negative 10, so that would make it an integer. And I can also write that as the quotient of two numbers, right? 10 over 1, or negative 10 over 1, which would also make it a rational number. So it can be any of those things. All right, here's the last one. Negative square root of 81. So this is a real number. And if I take the square root of 81, that's 9. So the number negative 9 is an integer. It's not a whole number. But I can also write negative 9 as negative 9 over 1, which is a rational number. So in class, you're going to get a lot of practice doing this, looking at different numbers, taking the square root of them, and comparing them for what types of numbers they might be classified as. So come with any questions you have to class, and I'll help you out.